Hello, welcome. Let's try to solve another Leetcode problem. 2454, next greater element 4. So we are given a zero-indexed array of non-negative non-negative integers of nums array. So for each integer in nums, you must find its respective second greater integer. So what second greater integer it means? So for example, this number 4. For this number 2, 4 is greater than 2, and another number 9 is also greater than 2, and then we're gonna get a 9. Yeah, for this number 4, 9 is greater than 4, and this 6 is also greater than 4, and it is the second greater element than 4. Yeah, so this doesn't mean this 6 must be more than 9, it doesn't matter. This 6 must be more than 4, so we're gonna get a 6, and similarly for this 0, it is 6, and for other two numbers, it is -1, -1. We know that if we are calculating the first next greater element, it's going to be easier. We just use a monotonic stack. We're going to prepare a monotonic decreasing stack, and for example, this element is bigger, and then for all those elements, we find the first next greater element. It must be this number. Maybe this is a 10, and this is a 9 to 1. Yeah. But our problem becomes we are going to calculate the second greater element. Maybe, for example, this is 11. Actually, for all those numbers, for 1 to 9, all those numbers, the second greater element should be 9. But how can we get 9? Yeah, because if we are using monotonic stack, if we are keeping a monotonic decreasing stack, basically, all those numbers, like from 1 to 9, all those numbers will be popped out from the stack. The stack gonna become empty, and then we're gonna get the result of this 10. So this is the first next greater element. But now we are going to calculate this 11. How can we get that? This means one stack is not enough. We have to prepare another stack. Yeah, so the idea is that we didn't. First of all, we're gonna pop out all those numbers from 1 to 9 inside stack 1. So this is S1. Yeah, so inside stack 1, we're gonna pop out all those numbers, and then we're gonna keep the relative sequence of all those numbers and put it inside stack 2. We're gonna prepare another stack. So inside of the stack 2, we're gonna keep the numbers 9 to 1, and then we're gonna check the stack 2 from the top of the stack from 1 to 9 because we want to keep the relative order. It should always be monotonic decreasing. If it is increasing, we cannot do that. Yeah, I will explain later. But let's just check. If we put the monotonic the stack 2 decreasing 9 to 1, it's like this. And then here is the number 11. And this is 11, for example. And here is nothing. Yeah. So for example, this is 11. And now we are going to pop out all those numbers. If we pop out this number and the placing, we're going to record it as 11 because this is going to be the second next greater element. And for all other numbers, it is smaller than 11, and we're going to have the result. Yeah. So maybe you think maybe we can keep the monotonic increasing. Is that okay? I mean, for the second stack, if we keep it monotonic increasing, it is not okay. This is because maybe this number is smaller. Yeah, it is here. It is bigger than some of the numbers, but not all the numbers. Yeah, but if we want to keep it a monotonic decreasing, yeah, we just need to put these numbers at the end. We don't need to pop out all those numbers after this position. This means we cannot do that. If we want to pop out a number, if we want to keep a monotonic decreasing, it is not possible. So it has to be like this. And then it is like this. And then we're gonna pop out all those numbers up to here and here. And at all those numbers while we pop out, we're gonna keep the record of which value it is. And we're gonna keep record of this value. Maybe this number is 5. Yeah. So this is basically the idea. We're gonna keep 2 monotonic stack. And they are both monotonic decreasing stack because we are going to calculate the next greater element. So we're going to prepare a variable n, should be length of the nums. And the stack 1 going to be our first stack. It's going to store the first greater element. And the stack 2 going to store the second greater element. Yeah, so we're going to check the result from stack 2. So we're going to keep 2 stack. and the result array gonna be -1 times the length of the array n. Now we're gonna use the monotonic decreasing stack to solve it. So for I, x in enumerate nums, so we are going to check the second stack first. Yeah, actually, while the code is running for checking the first stack, but for here, we're gonna check the second stack from here. If there's something inside of the second stack, of course, currently there's nothing. But if there's something, so we're gonna use a while check. So while there's something inside the second stack, and my value x is more than nums stack 2, the second stack -1. So this means I can record the result. Yeah. First of all, I'm gonna pop out the index. So I use the stack.pop, and I'm gonna record the result. So result j should be equal to x, because my second stack is for storing the second greater element. So I'm sure if I meet the condition, definitely I find it, and so I'm gonna record it. Yeah. So if I go out of the while loop, so this means yeah, basically I've finished part of my work. Yeah, so this means if I find the second element, I gonna store it inside. Yeah, but if the stack 2 currently, if it is empty, or if this is not possible, if it is less than or equal, so my first stack works. So for the first stack, I'm gonna prepare a queue. So I'm gonna use the dequeue because I want to keep the relative sequence. Yeah, I want to keep the relative sequence of the numbers. So if it is decreasing like this, I'm gonna keep the sequence. So for example, this number is here. Yeah, so I want to keep the sequence of all those numbers and put it inside the second stack. So similarly, it's gonna be the same while stack 1 and x more than nums stack 1 and -1. Similarly, I'm gonna pop it out. So j should be equal to stack.pop, and my queue should use append left because I want to keep the relative order. Yeah, even it is decreasing, I want to keep this relative order and put it inside the second stack. Yeah, so if I go out of the while loop, so my stack 2 should plus equal to the double added queue. So I would want to plus equal to this queue. And for the stack 1, should append the index I. Yeah. So yeah, so if there's only one monotonic stack, so it is calculating the only one next greater element, maybe the first greater element. Yeah, so we only have this lines of code and up to here. Yeah, but now we want to keep the relative order inside the second stack. So we just add this line and these areas to check the result. And basically the template is just the next greater element. Yeah, so finally we can return the result. Now let me run it to check if it works. Yeah, because this is stack 2. This is stack 1. This is stack 1. Yeah. Q.append left. Yeah, I want to append the index of this j. I want to keep the relative order. This is the stack 2. Yeah, now as you can see, it works. Now let me submit it to check if it can pass for all testing cases. Yeah, as you can see, it works and it's pretty fast. And the time complexity is O(n). N is 10 to the power of 5. Yeah, so this idea is really important for us to understand why we're going to use the 2 stack. So for the first stack, so for example, this number is here. And yeah, let me just use a decreasing one. Maybe So this is monotonic decreasing stack, and this number is here. So for all those numbers, we find the next greater element. So for these areas, we find the next greater element. But for all those numbers, so we're gonna pop it out. We will not do anything. Yeah, because it is more than that. We just need to check the smaller element at the left side. Yeah, so we're gonna record this and put this inside the stack 2. If we put it inside the stack 2, we're gonna check the next number. Maybe next number is here, maybe. Yeah, maybe it is here. So we're gonna check those numbers. So those numbers will have the second next greater element, and we're gonna put it inside. Yeah. Now, the loop still goes forward. Maybe after some time, we're gonna have another monotonic decreasing stack. It is like this, and we're gonna have a next number like this, and then we're gonna put all those numbers again inside the stack 2, and we put it inside the stack 2, and we're gonna check the next number. Maybe next number is here. So for all those numbers at the index, we're gonna record the result. Maybe this is 100. Yeah. So it can have the different cases, but basically it's like that. So for stack 1, gonna check the first greater element, and stack 2 gonna check the second greater element. If there is a second greater element, so we're gonna record the result. Yeah. So if there's nothing inside stack 1, maybe it is like let me find a better example. Yeah, maybe all the numbers is like this. Yeah, maybe all the numbers is like this. It is a decreasing. We can never find even the first greater element. There's nothing inside the stack. So we didn't do anything. We just return always to be a -1 because the array is decreasing. There's never has a greater element. Maybe there's only one greater element. We just put maybe there's only one. We just put these areas inside the stack 2. Inside of the stack 2, we have this kind of decreasing monotonic decreasing stack. But there's no such numbers that is even bigger than that. Maybe the number is here. It is smaller. So we will not do anything. So inside of stack 2, there's nothing. Inside of the stack 2, we have this kind of decreasing monotonic decreasing. Yeah, decreasing numbers. But we can never find the next number which is bigger than these areas. So we will record nothing. So the result would also be -1. Yeah, I think this idea is really important for us to understand it. Thank you for watching. See you next time.